Welcome to solverfy.
Now we have a cube that is sitting on the axis x, y, and z. That's x, y, and z, and it has side length a. The electric field around here is of the form E naught 1 plus z by a I cap plus E naught z by a j cap. Now, because the electric field only has x and y components, the flux through the top and bottom surfaces will be zero because the area vector there will be in the z direction. So if we simply find out the flux through these four surfaces, we can find the enclosed charge. So let's find the flux through the front surface. Now here, notice that the field changes with z-axis. So we'll have to integrate over z-axis. Now flux, as we know, is integral E dot dA. Now we have electric field dot. We know that the dA bar in this case will be in this direction, which is in the x direction. So that is, let's choose a strip on the side of the cube at a distance c of width dz. So, and the area of that strip will be, the area of this strip will be dz times a, and it will point in this direction, which is I cap. So this, when we do E dot I cap, only the x term will remain. So that's E naught into 1 plus z by a into a dz, integrating from 0 to a, which turns out to be a naught a into a plus a by 2, which is half E naught a square. This is the flux through the front surface. Now let's do the flux through the back surface. Now in the back surface, the dA bar will be the same dz into a, but the direction will be different, so it will be minus I, which means the flux through the back surface will be integral E bar dot minus a dz I hat, which will be integral of minus a E naught 1 plus z by a dz, starting from 0 all the way to a. I'm sorry, in the first case, this is 3 by 2 by the way. So here again, when we do the integral, we get minus a E naught times a plus a square by 2a, which would be minus 3 by 2 E naught a square. Now, let's find the field through the right surface. Here, we use the same method to find a strip and find its area. But notice that its area vector will be in the y direction, meaning dA is equal to a dz j cap. So the flux will be integral E dot a dz j cap, which will be integral of E naught z by a into a dz, which will be E naught integral z dz, starting from 0 to a. Before we finish this, if you notice something, the flux through the front and the back surfaces have cancelled themselves. Hence, let's look at the flux through the left surface. will have E bar dot. The strip will have the same area ADZ, except the area vector will have the opposite direction, giving minus E naught Z by A ADZ, which is equal to minus E naught integral Z dZ. If you notice, these two are equal but have opposite signs, which means they cancel. Hence, the total flux is equal. Total flux, which is the sum of all the fluxes, will be 0, which means the charge enclosed will be also be 0. That's it.